Good afternoon, students. Today we discuss about the Unit 4, Optical Properties of Material. Already the 50% of the syllabus covered in this topic in the classroom. Remaining 50% will be covered by the video classes. So already we know that optical materials, the materials are response to the light. Such materials are called optical materials. So there are three different type of optical material: transparent materials, translucent material, opaque materials, and already discussed in absorption and emission in metal and semiconductor and insulator. Scattering of light already discussed in this classroom. And then carrier generation. There are three different type of carrier generation: photo generation, phonon generation, impact generations. And then three different type of carrier recombinations: for radiation recombinations, Schottky recombination, and Auger recombinations. So these all the topics are covered in this classroom, but the remaining topic will be covered in these video sessions. So first we discuss about the solar cell. So here solar cell, LED, photodiode, organic LED, and its applications. So mainly solar cell is without any biasing, no battery connections. So solar cell is the solar energy converter. It is solar energy is converted into electrical energy. So this is the solar cell diagram. Basically this is made up by P and N type of material. Usually P type and N type is made up by silicon, and the green color indicate totally open window glass, and the black color indicates nickel plating without any biasing, but it is connected to the external load. Usually the P layers, N layers are very small, very thin region, so the incident light can easily reach the P-N junction and the electron hole pair will be created. So during the electron hole pair creations, the magnetic carriers are generated. So depending upon the intensity of the light, more magnetic carriers are generated. So this is our explanation. So if a photon collide with the valence electron, they impact them sufficient energy as to leave their parent atom. So in this way, the free electron and holes are generated on both sides of the junction, and their flow constitute the minority current. So this minority current is purely depends upon the illumination of light and the size of the surface area. So we discussed about the open circuit voltage. It's a main function of the illuminations. Solar cell output power depends upon the sunlight illuminations. So here nickel plated ring acts as your output terminal. So nowadays we can use the compound semiconductors such as gallium arsenide, indium arsenide, cadmium arsenides are used as a solar cell applications. So this is a solar cell VI voltage current characterization curve. So depending upon the different light intensity of illuminations, so in this circuit, open circuit voltage and output closed circuit voltage, the power output will be 0, and the maximum power output is obtained from the knee of the curves. So this is the open circuit voltage, short circuit current is maximum, open circuit voltage is maximum, but both conditions the power output will be 0, but the maximum power is obtained from the knee of the curves. So solar cell nowadays is used in batteries, is more efficiency level up to 15%. And then next topic will be light emitting diodes, LED, simply LED. So LED is operated on forward bias conditions. Basically is made up by P type and N type. So this is the P type, this is the N type, is the emission of light. So PN junction diodes are. So this is LED symbol. LED principle is forward biases. So positive is connected to positive, negative is connected to negative. So due to the forward biasing, that is the electron and the hole pair recombine. The recombination of hole and electron produce the energy in the form of photons. So this is a LED symbol, this is a LED construction diagram. So this is a P type and N type. This is a PN junction. It is connected with the forward biases. So due to the forward biases, electron hole pair will be created, and finally the recombination of electron and hole will produce a light. So this is the construction part. So N layer is grown on the substrate and the P layer is deposited by the diffusion process. So by using the diffusion process, the P-type and N-type layer will be grown. The carrier reconfirmation takes place. The P layer is deposited by the uppermost. For maximum light emission on the metal film, anode is outer deposit of the outer edge of the P-type layer. Next. So this is the working principle of LED. It's a P-type, this is a N-type, it's connected with the forward biasing. So this is the energy band diagram. When the PN junction is forward biased, in between the PN junction, the barrier width will be present. Due to the forward bias, the barrier width will be reduced, and then due to the reason, the potential energy is rising on the N side and lowering than the P side. The free electron and the holes have a sufficient energy to move their junction region. If a free electron meets